Alright, so number 9 on the study guide, a grain silo consists of a cylindrical main section with a height of 30 feet and a hemispherical roof. So if we're looking at this grain silo, looks like this. It specifies the actual height here. It says height of 30 feet. That'd be the cylindrical part, this bottom part here, so 30 feet from base to here. So that is the 30 feet. It's got a hemispherical roof, which would have the same radius as the circular top and bottom of the cylinder. So whatever the radius is here, the radius is also there, and the radius is also here. Tells us the volume is 15,000 cubic feet. We want to know what the radius needs to be. So we know the volume, we want to find the radius, and we're going to create this formula. It's not going to be easy to solve using normal means, so we'll be using Newton's method. So the volume of the cylinder is the area of the circular base, which in this case is going to be pi r squared. That's the best we can do, times the height, which is 30 feet. As with the previous problems we dealt with today, I'm going to use a calculator to approximate pi. So if I go 30 pi, I go 4 decimal places in my approximations, end up with 94.2478 r squared. So 30 pi is the numerical part, r squared is just attached to it. For the hemispherical part, volume of the hemisphere, a whole sphere is 4/3 pi r cubed. Hemisphere is half that, so 2/3 pi r cubed. So I need to figure out what 2/3 pi is as a decimal. So 2 pi divided by 3 is 2.0944 if I go 4 decimal places. 2.0944, that's r cubed. So again, 2/3 pi is the numerical part here, and r cubed is attached to it. And we know the volume of this particular grain silo, including the hemispherical section, is going to be 15,000 cubic feet. This is feet. Radius will be established in feet. So these two volumes added up should be the total volume. So 2.0944 r cubed plus 94.2478 r squared should equal 15,000. And we're trying to solve this equation, this cubic equation. If I set it equal to 0, then I'm ready to set up Newton's method. So if 2.0944 r cubed plus 94.2478 r squared minus 15,000 is equal to 0, that's going to be y1. So y2 is going to be the derivative of that. It involves some decimal multiplication, so let's just speed this up by using a calculator. So if I go 2.0944 times 3, we get 6.2832 r squared. 94.2478 times 2 is 188.4956. That's going to be r, and then a derivative of 15,000, of course, is 0. So now we have our function, we have our derivative. We're trying to solve this one. So this is why it's y1. The derivative of what we're trying to solve is y2. We got a y equals. We clear out what's already there. 2.0944 x to the third. Calculator doesn't understand anything but x. Plus 94.2478 x squared minus 15,000. Derivative is 6.2832 x squared plus 188.4956 x. I'm going to turn off y2 so I can look at y1. If I start off with the zoom 6 like we normally do, and we wait patiently, we see nothing gets graphed. That just means that the answer is not in between -10 and 10. Radius has to be bigger than 0, so I'm going to change my window, go from 0, try go to 20, and maybe that's big enough. And it is. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's a little bit more than 11. So I'm going to let r sub 1 be 11.2. Nothing special about that, it's close to 11. In the calculator it's going to be x instead of r, but that's irrelevant. So r is equal to 11.2 is our guess. We're going to turn on Newton's method program again, and we're going to put our guess in of 11.2, and it's going to tell us what the answer is. Does it specify decimal places? What the radius? So let's go a couple decimal places on our final answer. So let's go 11.28 feet. Again, all we're doing there is trying to find the root. That is the root, so that would be good enough. Number 10, we have a circular arc AB and a chord segment AB related to that central angle theta at center P of this circle. It says the length of chord AB is 4 centimeters as marked in the picture. The length of arc AB is 5 centimeters, also as marked in the picture. They want to find the central angle in radians, correct at 4 decimal places, and then give the answer to the nearest degree. So what I do know is the radius of the circle, whatever it is the same for both those segments. So P being the center of the circle, it does specify the central angles theta. That implies that P is the center. First relationship for the triangle part, ABP, we can use the law of cosines to relate the radii to the central angle to the force. So if I apply the law of cosines, this being the side opposite the angle I'm working with, it's going to look like this. 4 squared equals r squared plus r squared minus 2 times r times cosine of theta. Remember the law of cosines, that the side squared opposite the angle that we're doing the cosine of. And we always do this, the two sides we're not working with that aren't opposite, r squared and r squared, just like the Pythagorean theorem with this extra piece, minus 2 times whatever these two sides are not squared, times the cosine. If I simplify that as much as I can, I'm going to get 16 equals 2r squared minus 2r squared cosine of theta. And be careful, this 2r squared and this 2r squared can't subtract because this one's attached to a cosine of theta. Next, the relationship between the arc AB5 along with the radii and the central angle. When we're dealing with radian measures, which we're going to start off with, it's easiest to go radian measures. The arc length of a circle is radius times central angle. Again, that's as long as angle is in radians. So in this case, the angle we're going to assume is in radians. I'm going to assume the angle's in radians here. Anytime I get a theta in this problem, the theta is going to represent a radian measure. In this case, the arc length 5 equals the radius r times the central angle theta. And that gives me a relationship between r and theta that's easy to work with. Here's another relationship with r and theta not as easy to work with. So if I come over here and just solve for r equals 5 over theta, better known as 5 theta to the negative first power. And if I'm doing calculus, negative powers are usually easier than fractions. So 5 theta to the negative first. And I'm simply going to replace each of these r's with a 5 theta negative first. So 16 equals 2 times 5 theta to the negative first power minus 2 times 5 theta to the negative first power. Well, both of these should be squared. 2r squared, this be squared. 2r squared squared, cosine of theta. So if I square those and do everything I can do to simplify this, I'm going to get 16 equals, that's 25 times 2, that's 50 theta to the negative second, minus, that's 25 times 2, also 50 theta to the negative second, cosine of theta. And just like everything else we've done, if I set this equal to 0, so if I just chop this 16 off here and move it over here, all of a sudden I've got myself an equation with 0 on that side. So now that's going to be y sub 1. So 50 theta to the negative second minus 50 theta to the negative second cosine of theta minus 16 is y1. y2 will be the derivative of that function. 50 theta to the negative second is just a simple power structure, so we do the power rule. We get negative 100 theta to the negative third. The second term here, this times this, that's a product rule. And product rule is 1d2 plus 2d1. We're subtracting this term. So I'm going to put minus bracket or parentheses. Use whatever you want to use, but I'm going to put a bracket there. When I do 1d2 plus 2d1, the minus distributes after all that stuff happens. So 1, which is 50 theta to the negative second, d2 is negative cosine of theta, plus 2, which is cosine of theta. d1 is going to be negative 100 theta to the negative third. And then the derivative of 16 is 0. So then I just distribute that minus sign through. So the simplified version of y2, which is f of x prime, is negative 100 theta to the negative third. Minus times this is going to be two negatives make a positive, so it's going to be plus 50 theta to the negative second cosine of theta. I messed up. This should be negative sine theta. Derivative of cosine is negative sine, so this should be a sine theta here. And then minus that is going to be minus minus makes plus also, so plus 100 theta to the negative third cosine of theta. Okay, so we officially have y1 and y2 figured out, and I'm going to get these out of the way so it's not hard to see. So if I type those in as y1 and y2, we're going to get 50, oops, y equals, clear that out. We're going to get 50 theta, which is x, to the negative second minus 50x to the negative second cosine of x in parentheses minus 16. y2 is going to be negative 100 x to the negative third plus 50x to the negative second sine of x in parentheses plus 100x to the negative third cosine of x in parentheses. I'm going to turn off function 2. This only makes sense if this angle is less than a diameter. So pi would be a diameter, so theta has to be between 0 and pi. So if I wanted to just quickly just get an idea of where the answer is, if I set my window from 0 to pi, I'm in radians, not degrees. I simply want to see where it crosses the x-axis. Looks like 1, 2, a little bit after 2, so maybe about 2.2. So I'm going to let that be my guess. I'm going to guess that theta is 1 is approximately 2.2. And now that I have that information figured out, I'm going to go back to Newton's method, enter my guess of 2.2. You should find an answer near that. It says radians correct at 4 decimal places, so we have 2.2622 radians. And then it wants to change that into degrees. So that's the radian answer. If I want to change that into degrees, I'm just going to do 2.2622 radians multiplied by 180 degrees over pi radians. Make sure this is an equivalent measure, in which 180 and pi are the same. Radian cancels radian, so times 180 divided by pi. So 2.2622 times 180 divided by pi comes out to 129.6. It doesn't specify nearest to. It says give answer to the nearest degree. So that would be 130 degrees approximately. So that is your entire quiz study guide. Prepare for your test, and hopefully all goes well.